In this video, we will use the Taylor-Maclaurin series sum, LINEST polynomial regression, sequence data validation, and combine to generate the Legendre polynomials. We also use the chart to generate this. So we begin with the definition of the Legendre polynomial, which is equal to y times a times the quantity x minus 1 over 2 raised to the power k, where the value of k is 0 to n, and n is designated as from 0 to 10. So we calculate in 10 degrees from 0 to 10 degree. And our value for k is equal to sequence n plus 1 column from 0 to 1, increment of 1. So that when n equals 0, k equals 0. N equals 1, k is 0, 1. N equals 2, k is 0, 1, 2. N equals 3, k is 0, 1, 2, 3. N equals 4, value of k is 0, 1, 2, 3, 4. Now we enter the Taylor-Maclaurin series sum of the Legendre polynomial. A formula, series sum of the quantity that's x minus 1. X minus 1 over 2. And this is raised to the power k, where k starts from 0, incremented by 1, and the coefficients will be this range. And here we have the trend line and the trend line equation, which is also the Legendre polynomial. And this is to the polynomial to the 10th degree. So we could calculate the coefficients. So our formula, starting with the first term, which is combine n comma k. So combine n comma k, n comma k. So ours first term. So if this is 0, if this is empty, this should be 0. So we have to correct this. So if 0, so if it is empty, if k is 0 or empty, then 0. If so, k is empty, then 0. Otherwise, calculate. Now it's correct. If this is empty, this should be 0. Next, we continue with the second term, combine n plus 1 comma k. So this will be times combine n plus 1 comma k. Enter. Now we have the trend line and the trend line equation. Next, we calculate these coefficients using LINEST. To do that, we have to complete the 1 comma x matrix, where you have completing it using array formula of the x values raised to the power 0 to 10. That's 0 to 10. Now that we have calculated the 1 comma x matrix, so we use LINEST. LINEST data y and regress it to a polynomial to the 10th degree. So use data x. And we go back. So we start from 0 at n equals 0. Our polynomial, Legendre polynomial y equals 1. n equals 1, Legendre polynomial y equals x. So x, this is 1x. All these are 0. At n equals 2, Legendre polynomial y equals minus zero point 0.5 plus 1.5x squared. So minus zero point 0.5 plus 1.5x squared. At n equals 3, Legendre polynomial y equals minus 1.5x plus 2.5x cubed minus 1.5x plus 2.5x cubed. All these are 0. At n equals 4, Legendre polynomial y equals 0.375 minus 3.75x squared plus 4.375x to the fourth. So that's 0.375 minus 3.75x squared plus 4.37x to the fourth. And x to the fifth, or n equals 5. At n equals 5, Legendre polynomial y is 1.88 minus 8.75x cubed plus 7.88x to the fifth. That's 7.88x to the fifth. At n equals 6, Legendre polynomial y equals minus 0.3125 or minus 0.313 plus 6.56x squared minus 19.7 x to the fourth plus 14.4 x to the sixth. At n equals 7. At n equals 7, Legendre polynomial y equals minus 2.18 or 2.19x plus 19.7 x cubed minus 43.3 x to the fifth plus 26.8 x to the seventh. At n equals 8, Legendre polynomial y equals minus point or 0.273x or 0.273 minus 9.84x squared plus 54.1x to the fourth minus 93.8x to the sixth plus 50.3x to the eighth. At n equals 9. N equals 9, Legendre polynomial y equals 2.46x minus 36 point, that's minus 36.1 x cubed plus 141 x to the fifth plus minus 201 x to the seventh plus 95 x to the ninth. At n equals 10, Legendre polynomial y equals minus 0.246 plus 13.5 x squared minus 117 x to the fourth plus 352 x to the sixth minus 427 x to the eighth plus 180 x to the 10. This completes the use of Taylor-Maclaurin series sum, LINEST polynomial regression to generate a trend line polynomial to the degree 10 and the trend line of Legendre polynomials.